In this tutorial, we will explain how to create a project, perform an analysis, and review the results in Clockwork static analysis. The first thing that you need to do is have a project that you know how to build. For this tutorial, we will be using the GNU Chess, which is an open source project that you can obtain publicly for yourself. We will also be running it within the Sequent terminal, which is the necessary environment to build it within this machine. To analyze a project with Clockwork, you will need to trace your project. What we mean when we talk about tracing a build is to execute and run it with a tool called KWB Inject. KWB Inject will allow you to create a build spec, which will be needed for the next part of the demonstration. Before we begin, we want to show the list of the contents within GNU Chess, which includes files, of folders, and a makefile, and that will be the instruction to build this project, which is a C and C++ project. For example, we will be using KWB Inject to trace it, but it would also work if you had a Java project or a C# project to work with KWB Inject. In addition, we should note that it would have been a native build command, so if you want to have your project traced with Clockwork, then you would just add KWB Inject in front of it and then execute the build. This will trigger the native build, and you can see on the console that every line of source files has been compiled with G++. While it's being built, Clockwork is going to monitor this process in order to create what we call a build spec. A build spec essentially has instructions that will tell Clockwork how your project will get built and give it the understanding it needs to analyze your project. One good reason for doing this is that you get a better comprehension of what your execution paths are doing at the point of compiling it, which will provide you with a deeper understanding of the project than if you just used a parsing tool. This is why you need to have a project that can be built and compiled successfully. Once this is finished, we can move on to the next step. Amongst many things, what you're going to see is a lot of compile lines, which are instructions to Clockwork to say, we need to compile this file with these options listed off. You can also see some link lines that refer to improving the accuracy. Everything looks good, so we would say that this is a good build spec, which means that we're ready to go on to the next stage. To start the analysis, you will need to make sure to create the workspace. For our example, we're going to create the workspace in a new folder, and we're going to make a directory and call it Workspace. Next, you will want to set up the Clockwork local workspace. To do that, you will want to use a tool called KWB Check. While KWB Check has many functions and options, we're going to use it to create the project and then run the analysis. To create it, you just put the word create. You should see some folders that it has just created. One of these folders is going to be the database to store the defects, KWP local project LP, while another folder will be for storing our settings, Clockwork PS project settings. Now, if you're ready to start the analysis, you should already have the local analysis workspace in front of you, as well as you should have generated a build spec needed for the analysis. So you will just put it all together, and this is just running KWB check again with the run, and you're going to pass in the build spec as your option. So it was down in the directory, and it was called kwbinject.out. This is the default label, but it can always be renamed. Clockwork will then begin the analysis. It will then start by telling you the version you were at. It then does the build preparation and basically does an integrity check for the build spec. It will then run into the compilation stage. It has taken that build spec and it will compile a source file. The reason for doing that is so it creates an object file for itself to understand how functions behave within that project. This will allow it then to work out where all the exception paths are. This is very useful for a lot of diagnostics, for identifying where the execution paths are going to be leading to. If there's dead code or unreachable code, among other things, all that information will be part of a tailored list for showing results. In our example, you can see that it's using classic and modern, which means that we're using the hybrid engine of Clockwork. The reason for this is so Clockwork can maximize the fullest coverage of the C and C++ language standard. This is covering from the earliest languages before C++11 up to C++20 standard. If you like to get a full list of what compilers are supported and standards are supported by Clockwork, review our datasheet. After Clockwork has finished its compilation, you can move on to the analysis page. This is where Clockwork reports what defects are present at the end of the scan. Here you can see that Clockwork has told us what objects it is analyzing, along with the knowledge base files it has created. Knowledge base files are repositories of information for Clockwork to use when it's generating its report. Put simply, they are buckets of information that tell us how functions behave within that file. For instance, it would share information with us on whether this function receives an input that's greater than some value then returns 0, otherwise returning something else. It's these kind of signatures that we're looking for to build up our data flow picture of the project, as this kind of information is going to be useful in providing these interprocedural issues. As you can see on our screen, each one of these issues is listed as a thread number. This is using multi-threaded support from our operating system. If you find that your project is running slowly or hanging, it may be that you want to add more memory, or you just have more threads to be allocated to this. It's a process that can scale up very well, depending on how fast your underlying machine is. It's worth mentioning that it is running it as a full build from scratch. When you're running a sequential analysis, you'll be using some incremental features that will make the process speedier. But as this is the starting point, if you have not used Clockwork before, you will have to go through a full analysis first, which will then be used as a baseline for the future. Getting back to our example, since we just created this project for the first time and triggered analysis without specifying anything else, Clockwork will automatically allocate a set of default checkers. It's important to mention that Clockwork supports hundreds of checkers for C and C++. But for our example, we have selected a default list, which will be a balance between showing defects that will be of interest, including security issues, which can include buffer overflows, as well as reliability issues, such as null pointer dereferences, runtime issues, and maintainability issues. With a default set, you can strike a balance between performance and content, which should provide you with a good baseline to work with. If you're not sure what checkers to use, just go with the default and see what results you get. Once the analysis is complete, Clockwork will list the defects in the console. We recommend exporting this as a text file or something that you could easily share with your colleagues and project lead to say, here's how many issues that Clockwork found. Next, use KWB check, which will then give you a list of options that will enable you to list issues by different severities, so you can list them from number 1 being the most critical. For example, ID 504 is a local issue, meaning that it has been detected locally, and we can see what the source file is, which is source file line 337. It also tells us that we had an npd.gen.mite issue. NPD is an acronym for null pointer dereference. For all issues, Clockwork provides you with a little description. In this example, the description says there's a null pointer entry that comes from line 282, and it may be dereferenced at line 337. Information like this is printed by a console, and you can include it in a report. As part of our KWB checklist, we want to have a list of these critical issues, so we will do that again with our KWB checklist, but this time, give it a severity. Then we will add the report that we named critical issue list.txt. We will ask for the format to be detailed and open the text file in an editor. This provides you with the full list of the checkers on a text file. You could log this onto a page for a report or give it to the development team or project leads for their review as well. And that concludes our tutorial. For more information on how to get the most out of your static analysis tool, visit our library of guided tutorial videos.